So, hello and welcome back to the last topic of the course, and this is traffic simulation. So, at least in India, we face in a lot of traffic jams, and it's good when you are in a traffic jam, you really stuck to just look around and have weird questions. There's nothing else you can do at that time, and to have questions like, why isn't everybody moving? What is causing this traffic jam? If I was the transportation minister, what I would have done to really stop this kind of a traffic jam? Could we improve roadways or what? What could we do? And the answer, of course, lies in a simulation study, and therefore, this time we will be looking into traffic as something that we simulate. And the notion will be, at least for some part, or that I take traffic as a simulation exercise in this hour of the lecture. The attempt will be to first look at it in a macroscopic sense rather than in a microscopic sense, for which we've done a lot of use cases. We've discussed a lot of things. So this will be the only example where I look at the macroscopic point of view of simulation. So all the traffic vehicles will be just entities into a distribution, and I'll see how does the distribution behave and how is it expected to behave as different things happen. Now, traffic simulation, of course, is something which is fundamentally useful. It'll be easy to say just build a flyover. So the users went into this route and there was a traffic jam one day, and they all tweeted from their mobile phone, we want a flyover, so let's just provide one flyover. However, the problem is it's gonna really cost in crores of rupees and a lot of time and effort, so you really need to do a cost benefit analysis that, okay, we can give one, this is the expenses, this is the time. However, this is the performance improvement that we'll be getting. So if it was just a rare traffic jam, it will be really good to not have a flyover. If it's recurrent, it'll be good to have a flyover so that the transportation efficiency can be increased. The people will get to their offices on time, they'll be more productive, the joy of living will increase. So it's nice to do all this cost benefit analysis. How do you do it? Using traffic simulation, of course. So similarly, another example is that I decide to build a flyover and I measure how much is transportation efficiency increasing, based on which I try to decide how much are the people able to save on the fuel, and then I could say that, hey, I saved you this much amount of fuel, so your journey costs this much less, so give me toll tax. So people will be willing to pay because they save time, they save fuel, and whatever the fuel that they save, they'll be happy to give it to the government. So eventually that flyover will become profit bearing. Similarly, another thing that we care about very much, and it's very difficult to call it as a cost benefit analysis. So a lot of accidents happen because of problems in the transportation networks. So people want to drive at high speed, people really want to drive in at crazy speed. There are intersections and they don't just wait to look around, and they just go around causing a lot of traffic chaos. So if I build things like a flyover, of course that also saves life. Eventually down the line it saves life. If I can minimize the vehicle and the pedestrian intersections, if I can minimize that interaction, then I do save life. If I can improve my transportation infrastructure, then I do save life. And then again, it's a big question. Do you invest in crores and crores of rupees, or you unfortunately leads to a few accidents. Unfortunately, a few of them may be extremely fatal. So that's another kind of analysis that you need to do. You need to find out how is it doing in terms of the environment. So these days environment is also on a major clash, so you need to simulate to find out what is the reduction in carbon footprint if you have these nice smooth roads, and if you don't have that, how much are the vehicles emitting more. And then you go on to an environment industry and say, okay, these many crawls, I build these roads, I build these flyovers, I minimize these intersections, this much is the save of carbon footprint. Do you believe it's major, or it's just a small little improvement in the carbon footprint? So maybe instead of investing money on all this road infrastructure, I invested somewhere else, like advertising and asking people not to pollute, or in investment in banning certain kind of products and certain kind of packaging material, which again will have in another impact. So there's really a lot that you can do with traffic simulation. So you just simulate in a traffic, and after you've simulated a traffic, you see what is the transportation efficiency, fuel saving, how much is the risk involved, how much is the reduction risk involved, how much is the time getting saved, and so on and so forth. And if it's really worth it, you develop the infrastructure, you make in driving rules. How do I decide whether the travel speed has to be 60 kilometers per hour or 30 or maybe 10? Of course, there are de facto rules, like around schools you cannot drive at high speeds because kids don't know the traffic rules, they won't obey them. In fact, even senior kids don't know the rules. Our college campus is the best example. Nobody looks around before crossing a road. All the couples in our campus will casually walk around as if it's their own road. So you cannot have high driving speeds. That's why we installed in speed breaker as a policy. It wasn't that there are too many vehicles or it was a risk in any other case, but it's just that we wanted to restrict the travel speed, so we installed all the speed breakers and all. So there's so much that you can do with traffic simulation. Now, every simulation will of course need in certain inputs, and now all these examples were real life, so now I cannot just say that take random synthetic inputs as we had been doing so far. So I'll have to give you what are the real life inputs. So if I need to do a traffic simulation in order to tell an authority to take all these decisions about travel rules, about the development of infrastructure, about where all pedestrians can go, where should pedestrian crossing be, at what speed should everybody drive, I need some inputs, and of course the output will be the simulated traffic and all the performance metrics that we were talking about. And the model for all the performance metrics are pretty much standard. You know how much mileage does your vehicle give in different conditions. The manufacturers from which you purchase all the vehicles and the bikes, they have all those test results. So now the first input is of course a road network graph. And these days we don't talk about it because everybody knows it's available as Google Maps. If you are the open source guy, it's available from OpenStreetMap website. And getting this input as a technical problem is also pretty simple. So the first standard way by which you can get in this kind of an input is when you say that there are satellite images which are available, and using satellite images you can approximately find out where are the roads. And if you know where are the roads, you can really have computer vision algorithms into picture which try to trace down all the roads, and wherever two roads intersect, that's what's an intersection. So it's easy to develop, and of course it's at a macroscopic level. So even if you get something which is more approximate, you can crowdsource it up. You can ask all the users to really pull in their expertise in correcting that road network graph. So previously we looked into SLAM algorithms, and that's another thing that can happen. You install a high precision GPS along with other sensors which perform simultaneous localization and mapping if you want. and let this vehicle drive the length and the breadth of the city, irrespective of the city that you live in. These are not extremely large cities, so you can actually travel the length and the breadth within a few days. If you live in a city like Prayagraj, then probably a day is enough, and as the vehicle moves around, it makes in a detailed map using all the rich sensors that it has. We are talking about macroscopic level. If you don't need a centimeter grade accuracy, then a high precision GPS will itself be able to do a reasonable job, and you get your road network graph defined in such a manner. Better still, even at the classic times, you had cartographers who made the road network graph. So whenever a road had to be tendered out, they were the ones who drew the map, and then that map was given to the people in civil engineering to make the road network graph. So even when there wasn't a GPS, when there wasn't satellite imagery, and there wasn't all the technology that we talk about today, the road network graphs exist because of that obvious technology. When you construct it up, you make it in the map. So those are the standard, not talked about much these days, cartographer skills, where the humans would be expert in making in maps using all the measurements. All older maps are made by humans. So getting a road network graph of a city is absolutely easy, and that's the first input. And even in a multi-agent simulation, the first thing that you did was to take in a map of your lab, of your office, of your warehouse, and to simulate different things. So that's all that the map is. I don't need really which hotels are nearby. For a road network simulation, I don't need what does the intersection look like. Is it a nice, beautiful intersection, or it's dull looking? In my simulation, all these factors will not come into play. I will not come into a major play. Now, the second thing that I also require as the input is what is the traffic flow information. In all the simulation that we've done, we had something called as the source of every agent and the destination of every agent. And our simulation so far started absolutely any point of time, but what I also needed at what time is the person at the source. Now in traffic, the source is called as the origin, the goal is called as a destination, of course. So it is the origin destination information, or it's called as a OD matrix, the origin destination matrix, and time is silent. So it's actually a 3D matrix which says from which source to which destination at what time, how many vehicles flow. Remember, it's macroscopic, so I won't say one vehicle goes from IIIT Allahabad to several lines. I will say at this much amount of time, 25 vehicles go from IIIT Allahabad to several lines. So that's my OD matrix. So it'll look something like this, where the third dimension is, of course, of time. So this is my origin, this is my destination, and this is my time. And this cell around over here, it says from IIIT Allahabad, so from IIIT A to civil lines at 6 p.m. You know what happens, classes get over. So from IIIT Allahabad to civil lines at 6 p.m. Let's say 25 vehicles, these are Olas, move because users want to get in. So that's at the level of what is the origin destination, or what's the demand of the transportation infrastructure. Now the same information can be summarized in at traffic flow information. So this is what we'll require generally as an input. In general, what I aim at recording is at every road, at every time, how many vehicles move. So what's the flow at every road? How many vehicles move at every road? That's the kind of information that I'm looking at. At every road, what's the flow information? At every road, what is the kind of flow information that I have? And that's something that I'm trying to look in this system. Now it turns out that today we're talking about Prayagraj as a smart city. Of course, around the world, smart city concept already exists. It's not something which is adamantly new. And when we say that it's a smart city, one of the things that we do mean is that we have a smart transportation system or an intelligent transportation system. What that means is that even to a very large extent at a city like Allahabad, also what we have is that you've got different intersections, and all the different intersections that lie around have smart cameras. And what happens when the smart camera is at the intersection, you know how many vehicles are coming. The smart camera can approximately count that vehicle, and of course the smart camera has a timestamp. So you know at every time how many vehicles are coming into an intersection, and of course they would have been into the road at different times. So that's one source by which you get in the vehicle information. So I assume that every single place has something like a smart camera. So that's my intersection where different roads meet. And as soon as you come here, there's a camera kind of a system over here, over here, over here, and that's doing some basic kind of accounting. So I know at every particular time how many vehicles are there over here, how many are there over here, how many are there over here, how many go from here, and so on and so forth. That's one way you can get it. Now, luckily, there's another easier system, and this one is called as a loop detector. So what really happens is that this is your road, and you install in a device underground like this. And what really happens is when the vehicles, remember that we are talking about big vehicles, and when these big vehicles move, they produce a lot of vibration. These vehicles produce a lot of vibration. And because these vehicles, they produce a great amount of vibration, so there are sensors which vibrate because of these vibrations produced by the vehicles, and I measure the vibrations, and using that I get an idea about how many vehicles have moved. So these are called as loop detectors. So unfortunately not currently in India, at many other places, when a road has no vehicles, the traffic light doesn't wait. For that, the traffic light needs to know that there are no vehicles around over here. How does it come to know? That when there's great signal and the vehicles are moving, they produce vibrations. When the vibrations stop for a long time, when the vibrations stop, then there's no vehicle. So why turn it green anymore? There is no vibration. So these are called as loop detectors, and then again my loop detectors, they continuously measure the number of vehicles that flow with time, and they continuously keep a log of how many vehicles are passing by at different points of time. So again I know what is the flow or the number of vehicles at different segments of the road at different points of time. Luckily, the loop detectors, although they are installed at the intersections only so that they can be integrated with traffic light, in general they can be installed absolutely anywhere else. Now we don't use it much for transportation, so it's rarely used, but then the humans when walking don't produce any kind of vibration, and if you really want to measure in humans, you can do it of course with the help of a proximity sensor. So these are the sensors which are used very well. So when the humans walk in, so this sensor will get a tick, it'll get a vibration, And that's how where you can measure how many humans are passing by or how many bicycles are passing by on a bicycle lane. So that information is again something if you need it. It obviously can be measured. If you need that kind of an information, it obviously can be measured about the number of road users, the number of bicycles, and so on and so forth. So that's again a quantity which can absolutely be measured. It's not actively used in transportation. That's why many parts of the world you have those pedestrian lights. You press a button, they turn green, and then you walk. But after you stop walking, it's not that the light turns red immediately because that light doesn't know pedestrians are walking or not because something like a proximity sensor is not over there. You can also do it by other devices like the one that they use it in smart homes. So when you walk, the light automatically detects you and it switches on or switches off. So that can be based on the human heat or the based on these kind of proximity sensors, whatever kind of sensor you use. Of course, not actively being used into the transportation system now, but then, of course, where we are getting into is the fact that for a transportation system, getting the traffic flow information is absolutely possible. Using all the sensors which exist in a smart transportation system, getting this information is absolutely possible. And when I say getting on this road network infrastructure, getting this traffic flow information is absolutely possible. Then I can also extract the origin and destination. So you have a road where you saw that 25 vehicles come here, but only 10 leave. So the other vehicles belong to people over here, most probably, and the vice versa 25 leave, 10 enter. So, some people went in over here or went out over here. So that kind of an information again is something that can be extracted once I have the traffic flow information, which will give me the input that I need for the transportation system. The other way around, if you just need it for a few segments, it's another simple exercise. If you just need the traffic flow information for a few segments lying here and there, it's another similar exercise. And in such a case, what you do is that you send in smart vehicles. The smart vehicles are, of course, the one that are rich with sensor. So that's your road network graph. So you send in service level smart vehicles around over here. And once you send service level vehicles, smart vehicles around over here, so what they do is that they travel around and they gather information about the traffic. They gather at what speed are they moving, they report it up. Based on that, based on how much vehicle density are they observing, how many vehicles are they observing around, they estimate the traffic density and report that. And they do it for all around. The density and the flow, of course, will have a smoothing effect. It's not that suddenly it's very large, it will automatically deteriorate very quickly. That's not going to happen. So what these vehicles really go about doing is, at certain times, you know what was the speed information, what was the density information, what was the traffic flow, and that information will be smoothed around. If you ever wondered how does Google estimate your travel time, it's again the same thing. So you carry with yourself a smartphone as you navigate. It's Android driven, that's Google, or it's using Google Map, iOS or Android, that's Google. So using your own GPS and IMU, of course, Google is telling you where you are. So you are getting that information just to be sure that you're traveling correctly. It always knows this thing. But what the service provider is keeping with itself is at what speed are you moving. So in a general traffic, so many users of smartphone and all their motion information is there, which is being uploaded at the service provider's servers. So it knows at what time, at what intersection, how much is the traffic, what is the travel speed. It knows everything. So once it knows everything, so that's again, so your vehicle is like this intelligent vehicle and your phone is like that smart sensors on the vehicle which are continuously reporting traffic information to the service provider. Currently, we don't have open standards where this information is being actively shared, but that's possibly the future where all this information will also be shared with other people who can do intelligent algorithmics and everything around that. So, I got in a whole lot of information like this, which is absolutely available to me. I've got an access to all this kind of an information. And the aim is therefore to make in some kind of a simulation framework or to study some kind of a simulation framework, which is what we will be studying next.